Okay, so this is question 9 from the 2019 Ordinary Level Maths Paper 2. R is a radar station located 120 kilometres north of the port P. Let's see if we can get all this diagram in. So there's your port P, and R is a radar station. The circle C is centred at R, so that's your centre of the circle, with the radius of 100 kilometres as shown. With the radius of 100 kilometres shows the detection range of the radar. So that's your radar will detect anything on the circumference of that circle. When a ship enters the circle, it will be detected by the radar station at R. Figure 1 shows a ship leaving the port P, sailing in the direction north 30 degrees east. The ship enters the circle at S and exits at T. At Q, the ship is closest to R, and PQR is 90 degrees. So it's a right angle. So we've right angle triangles here. So you're looking at your trigonometry with right angle triangles. So the triangle PQR, that's there, is taken from the figure 1 as shown. Okay, so find QR, the length of, find QR or the length of QR. So for this, you're going to go to your tables and you're going to use Pythagoras' theorem. Okay. Oh no, sorry, are you not? Oh no, we're going to use the sine rule. I think we could have used Pythagoras for this. Oh, because we have the 30 degrees, so we may as well use the sine rule, it's easier. Okay, so the sine of 30 is A over C. Again, if you go to your papers, go to your right angle triangle, and it'll tell you that the sine, the cosine, and the tan, that they're A over C, B over C, and A over B. So you have the sine and you have C, an angle in C. So what you're looking for is you're going to use the word sine. So that's the first thing to identify. So what angle have you got? Okay, and what line have you got? That's C. So you have that and C, and you're looking for this one, which is A. So you have A, you have C, you have an angle, so you're using the word sine. Okay, so you'll see that in your tables. So the sine of 30 is QR over 120. Okay, because you know that C is 120. So multiply the whole of that. This is like algebra. This is like a whole equation. So you want QR on its own. So multiply your whole line by 120. And you get 120 sine 30 is equal to QR. Use your calculator. Just put into your calculation. I'll show you how to do that. 120 sine 30. And press equals. Okay. And you'll see that QR is 60. Right? So that's how you do that bit. So next we have the triangle QRS. Again, it's taken from figure 1. We have it here. And use your answer from part A to find QS. So we're going to use Pythagoras' theorem here. C squared equals A squared plus B squared. C is 100. We know that from here. A is 60. We worked it out here. And B is QS. This is what we're looking for. So 100 squared equals 60 squared plus QS squared. So 10,000 equals 3,600 plus QS squared. Take the 3,600 to leave QS on its own. Whatever you do from one side, you have to do to the other side. And you end up with 6,400 equals QS squared. Want to know what QS is? So get the square root of 6,400, and that is QS, which is 80. So your answer is 80 kilometres. Next, we have to find PS, and again, give your answer to the nearest kilometre. So again, we're going to use Pythagoras' theorem. C squared equals A squared plus B squared. C is PR, and if you look at the page before, you'll see that that's 120. A is QR, and if you look at the page before, you'll see that's 60. So put that into your formula instead of the C and the A, and you have 120 squared equals 60 squared plus PQ squared. So the same thing again. 14,400 equals 3,600 plus PQ squared. Take your 3,600 from both sides, and you're left with 10,800 equals PQ squared. So to find out what PQ is, get the square root of 10,800, and PQ is 103.92304. It says to the nearest kilometre, so to the nearest kilometre, so PS, so that's PQ. We're looking for PS. Don't go to the nearest kilometre till you get to the very end. So in your diagram, you'll see that PQ is like from there to there. That's, say, PQ. And P is there and Q is there. And S is here. Okay? So to find out PS, it is PQ minus QS. Okay? If you have that line and you take away that line, you're left with just that line. So PQ is 103.92304. QS is 80. So PS is 103.92304 minus 80. It's 23.92304. Rounded up to your nearest kilometre is 24 kilometres. Okay, so don't forget that once you have PQ, PS is PQ minus QS, and that's how you get your PS. Okay, so next we have consider the triangle RST. Use the cosine rule to find an expression for cos of theta, where theta is the measure of the angle, TRS. Hence, show that theta is 106 correct to the nearest degree. Hence, show that means that it is. So you should get 106 when you correct it to the nearest degree as your answer. So first of all, TS is the diameter. Where did I get that from? Oh, never mind that, the diameter. Sorry, I'm in Egypt. Q is the halfway mark is there on the original, and it is the halfway mark between T and S, okay? Because it's at a right angle to there, so that bisects the line in half. So that's the halfway mark. So TS is twice QS. And we know what QS is. We know it's 80. So TS is twice 80. So it's 160. Okay, so then you're going to use your cosine rule, which is A squared equals B squared plus C squared minus 2BC cos theta. A is 160, B is 100, C is 100. So you put that all into your formula. 160 squared equals 100 squared plus 100 squared minus 2 by 100 cos theta. So you end up with 25,600 equals 10,000 plus 10,000 minus 20,000 cos theta. So obviously 10,000 plus 10,000 gives you your 20,000. So you've 25,600 equals 20,000 minus 20,000 cos theta. Now I want to leave the 20,000 cos theta on its own, so I'm going to take the 20,000 from both sides. So subtract 20,000 from both sides of the equation, and you're left with 5,600 equals minus 20,000 cos theta. So to find out what cos theta is, you divide both sides by 20,000, and that gives you minus cos theta. So 0.28 is minus cos theta. Now I want cos theta. I don't want minus cos theta. Sorry, I've forgotten to move this down. So let's have a look at that again. So we were here. You have 25,600 equals 20,000 minus 20,000 cos theta. So you can't subtract those two because that's attached to that. So we're going to subtract this from this side and this from that side. So subtract those and you're left with 5,600 equals minus 20,000 cos theta. Divide by 20,000 both sides and you get 0.28 equals minus cos theta. We want cos theta, so change the signs. So minus 0.28 equals cos theta. So there you go, cos theta equals minus 0.28. So to find out what theta is, in your calculator, you put in shift cos, because you want cos minus 1, minus 0.28 equals, okay, 106.26. And when you round that up to the nearest whole number, you get 106. Did you see that on the calculator? Yeah, were you able to see that, or did I have it too low down? Let's do that again. So to get cos that, you put shift cos, and that gives you your cos minus 1. And then you put in your minus 2.8, minus 0.28. Sorry, I said it the wrong way. And press your equals, and you get your theta. Okay? So now we have John sails directly from S to T. Okay, there you go, from S to T. Mary sails from S to T along the arc there. That's called the minor arc from S to T. Find the difference between the distance that John sails and the distance that Mary sails. So also you're going to find your two distances and then just subtract them. So let's first of all find the arc. So the formula for the length of an arc is 2 pi r multiplied by theta over 360. R is 100 because we know that from here. Theta we've worked out is 106. So in your calculator, put in all in brackets. I put that in brackets as well. But you can put it by multiply by that, but I think it's better if you put it all in brackets. Bracket 2, bracket pi, bracket 100, bracket 106 over 360 equals 185.0049. Okay, so that's how far she travelled. ST is the same as TS, which we already figured out was 160. So 185.0049, subtract 160, and you get 25.0049. You want it to the nearest kilometre, so that's 25 kilometres. Next we have that the sea in this region is estimated to have an average of 1 ship per 25 square kilometres at any time. So use this estimate to find out the number of ships in that sector, RST. Okay, so in that shaded bit. Give your answer correct to the nearest whole number. So that is, you're looking for the area of RST. Now it's the area of an arc. That's what you're looking for in when you go to do it, an area of an arc or segment. You'll see it in your maths tables. It's pi r squared by theta over 360. R is 100, theta is 106. So again, all in brackets, put it into your calculator and you get 9250.245. So that's bracket pi, bracket 100, bracket 106 over 60 equals 9250.245. Divide that by 25 because there's 1 ship per 25 square kilometres. So to find out how many ships there are, divide that by 25. So that divided by 25 gives you 37.0098. Now you're not going to round that up. If that was 370.9, you wouldn't round it up to 371 ships because 0.9 of a ship isn't a ship. So you just take the number before the decimal point, and the number before the decimal point is 370. So it's 370 ships. And that is question 9.